Okay, welcome back to the 6th GCSE Maths lesson that we're going to be doing. So as per request, we're going to start doing interest and depreciation, which are very, very tightly knit topics. Okay, so it's essentially the exact same equation in both senses. So we should probably talk about interest and depreciation to start with. So I think the easier one to start off with is going to definitely be interest. So when we talk about interest, we have two types of interest. We have compound interest, and we also have something called simple interest. And honestly, it can be a bit tricky to kind of wrap your head around these two. So with compound interest, actually let's start with simple interest. With simple interest, the amount of money that you gain stays the same each and every year. Okay, so we should also mention that interest generally refers to bank accounts or some kind of investment. Okay, so that's where you'll see the words interest. Okay, you also see interest on loans and things like that, but for the purposes of kind of GCSE Maths, it's normally bank accounts with saving interest, so like 2% interest per year or whatever, or that they invest it in some kind of savings account or stocks or whatever it is. Okay, so essentially interest is the amount of money. So if we were to just quickly write this, interest is money gained per year. Okay, so that's all it is in a nutshell. Now there's two types of interest. You have compound and you have simple interest. With simple interest, the amount is fixed. Okay, so for example, if I invested £1,000 and there's 2% simple interest, then what I do to work out how much I get per year is I just work out 2% of 1,000. So 1%, you divide it by 100, so that would be 10, so it's 2 times 10, it's £20. So every single year, you get £20 into your bank account, or portfolio, whatever you want to call it, okay? So £20 every year. So after 10 years, so all you do is you do 10 times 20 equals 200. You've gained £200. Perfect. So in total, you would just have £1,200. Okay. It's called simple because it doesn't change. Okay. Once you know how much you get per year, that amount is fixed. Compound interest is a bit more interesting. That was an accidental pun, I promise. The amount you get changes every single year. Okay. So to explain this, so first off, the amount changes. Okay, so let's say once again use the exact same example. We have £1,000 and we have 2% interest. Now these numbers are going to get very ugly very quickly. Okay, after the first year, it's the exact same thing, right? So 2% is equal to £20, right? You work it out the same way. So after 1 year, you have £1,020. Now to work out how much you get for the next year is you need to work out 2% of 1,020. Okay? So that would be £20 and 40 pence. And then you add that on. So in the second year, you now have 1,040.40. And then to work out for the third year, you do the same thing. You take 2% of £1,040 and 40 pence and add that on, and so on. So the amount you get increases every single year. Okay, that's pretty tricky to kind of work out, right? You don't, like, if I asked you, okay, after 10 years, how much do I have? You don't want to do this 10 times. It would be here forever. So thankfully, there is actually an equation we can use to work it out. Okay. Now, if something increases by 2%, it's now at 102% of the original value. Right? Because 100% is its normal value. So if I've increased it by 2%, it's now at 102% of its original value. So what I can do to work out the amount that we have, and let's say it's after 10 years, we take our original investment of £1,000, times it by, now 2% would be 102%, which as a decimal is 1.02. So you put 1.02 to the power of the number of years. Okay, so if you want an actual equation for this, you have final equals initial. So final amount of money equals the initial amount of money times the percentage to the power of the number of years. Okay? So Evie, does that make sense? It's very tricky to wrap your head around, but once we do some questions, I promise it'll be a lot easier. But this is why compound interest can be a bit tricky. Okay? But what I hope you take from this is this part here. If something increases by 2%, it's at 102% of its original value. If it increases by 10%, it's at 110%, and so on. Right? You're just plussing and minusing from 100%. Okay? Are we all okay with that so far? Once you do some questions, I promise it'll be a lot easier. Although I think the first question on this is a bit tricky. Let's get started. Okay, cool. So, we have Jessie invests £8,000 for N years, so some number of years, in a savings account. To find the value V of her investment after N years, she uses the formula V equals 8,000 times 1.025 N. Now, if you remember my equation that I wrote just now, it was amount equals, well done, perfect Evie, well done. So initial times 1.02, it wasn't 1.025, I got confused there. But Evie, you're 100% correct. To the power of the number of years, right? That looks exactly like her formula. But £8,000 is the initial, so they've just replaced initial with £8,000. Good. So the initial amount's £8,000. The percentage is 1.025, and as Evie said, that means the interest is 2.5%. All we look at is the bit after the 1. 0.025 as a percentage is 2.5%. Perfect. Okay. Find the total amount of interest. Okay. So the actual value, right, using V, is going to be 8,000 times by 1.025. It says in 3 years. So my number of years is 3. Okay. So what we're going to do here is, I've got my calculator here. We have 8,000 times 1.025 to the power of 3. Now this is what her investment is worth after 3 years. Exponentials, as in e to the power of something. It's like e to the power of 2x or whatever. Not in this lesson, if so. And the final value of the investment is 8,615. 0.13. So you might notice it says 125, but with money we always round to 2 decimal places, right? You don't have 0.5 of a penny. Okay. So this is kind of like that, Evie, right? Because I can write this as 8,000 1.025 to the power of 3. So it is very similar to a times b to the power of x, right? It's similar. This is more like an introduction to it, but I will cover it a bit later. Okay, but this is actually an exponential equation like you just said, so well done. Yeah, I will. This is an exponential equation in and of itself, right? But are you talking about like drawing them and things like that? Or just in general? Yeah. Now if you look at the original question, it says the amount of interest earned. So then yes, I will eventually. So to work out the amount of interest, all we do is we subtract the initial investment. So the actual amount of interest, so if I write interest, is £615, 13 pence. Well done, Lila. Exactly right. Okay? Exactly right. So not bad. 3 marks. I think that's pretty good. You can do it all on a calculator fairly quickly, fairly easily. Okay. So we have Perry again. So invest £25,000, 3 years, 2.7% compound interest. So again, if we use that equation, the final amount will be the initial investment of £25,000. Again, we're just using the equation I used here. Initial is 25,000 times. Now the percentage as a decimal, right? It's 2.7% interest. So it's going up to 102.7. So to work it out, all we need to do is divide that by 100, which hopefully you can see would be 1.027. Right? And if you're not sure, this will only come up on a calculator paper, by the way. So with compound interest, it has to be a calculator paper. So don't worry if you're unsure. Then 3 years is to the power of the number of years, and that's it. So once again, whip out the calculator. If I change it just from left to right, we have 2.7. We have 25, 1, 2, 3. And again, round it to 2 decimal places. So I'll hide that just for a second. Again, just to show you what I got on the calculator. It's that, to 2 decimal places. But again, if it's asking specifically for the amount of interest, you subtract the initial investment, okay? So we're going to take away, so for the actual interest, what we're effectively doing is 27,080.17 minus the initial amount. If they ask you what the final value is, this would be our answer. But if they ask us for the interest, we have to subtract 25,000. So that should be £2,080 and 17 pence. Okay. Again, 3 marks. I think that's pretty quick. It's not bad, right? Not too bad. In my opinion, anyway. Leave that there for a second. Perfect. Again, just make sure you stop me the second you find something you're a bit stuck on. Okay. Good. So this gets a bit trickier, but I'm going to show you 2 ways to do it faster and easier. Okay? But I'm going to show you a really long way first. Okay? And then I'm going to show you 2 ways that will make it, you can do it in 1 line. Okay? But I need to show you it a long, tedious way first, okay? But if you're ever unsure, do it the really long way. So we have a house for £350,000, okay? First year, it increased by 3%. Then it increases by 2%, again in the second year. Then it decreases by 5%. When something depreciates, it means it loses value. So in this case, you can think of it as the opposite to interest. Okay? But depreciate in general means to lose value. So in this case, it's the opposite to increased. Okay? So in terms of, instead of it being interest, it's depreciation. Okay? Work out the value of the house at the end of 3 years. So the first way I'm going to show you, which is the longest way, is to just work out how much it changes by each year. So if I write this out as first year, we have a £350,000 house, and it increases by 3%. So that's the same as it being 103% of its initial value, right? So I'm going to times it by that as a decimal, which is 1.03. So again, while I type it in, if you're unsure, please do just stop me. 350, 123, multiplied by 1.03. You get £360,500. Good stuff. 360,500. Now the second year, this is where things get a bit more interesting. The house price increased by 2%. So we're going to times it by, it's 102%, right? That's all good. So 1.02. But keep in mind, it's increased from this value, not the 350,000. So it's increased again by 2%. So instead of 350,000, I have 360,500 times by 1.02. Right, so the house increased by 3% up to that level, then increased by 2%. So it's increased by 2% from that value, not the original one. Okay? So again, what we can do is we do 360,500. Hang on a minute, I wrote that incorrectly. There we are, 360, oh my goodness. 360,500 multiplied by 1.02. So 367,710 £10. Okay. So again, I'm showing you this long way, and I know that it's long, but trust me, there's a reason why I'm making you do it the long way first. Okay. So again, if it's now depreciated by 5%, right? So it's gone down by 5%. Now, there are actually two ways to do this as well, funnily enough. But if it's decreased by 5%, can you see that it would now be at 95% of its original value? Right? So when it increased by 3%, good, perfect, Evie, well done. Lila as well, perfect. Yeah. So 100%, if it increased by 3%, it goes to 103. If it decreases, it goes down. Right? 0.95. So I'm going to times by 0.95, which is a number less than 1, which means the number should decrease. Okay? I'm going to show you. So 367,710. And we get £349,324.50. Okay, so that's our answer. That's 3 marks. Okay, bear in mind this is 3 marks, so 3 steps make sense. I'm going to show you a new way, right? So it was kind of tedious when we had to keep rewriting the number, right? Here's a tip. We can use the answer button, the ANS button here, and it saves whatever our last answer was. Okay? So what I can do now is I could do 350,000 times 1.03. If I started from the beginning, equals. Then I just press times again, and it gives me answer times. Or I can just do answer times the next one, 1.02 equals. Then I press times again, 0.95 equals, and I get the same answer. All I'm doing is just pressing times again and again and again. Right? So the second method is using the answer button. And all it saves you doing is writing out the same thing again and again. So we're all okay with the second method. So Lila, Evie, is that all okay with the second method? Evie, that is exactly what the last method is. This is the fastest method. Perfect. So Evie, you just said the perfect thing. If we're just timesing 3 things in a line, what I can do is exactly like Evie just said. So I can do 350,000. Whoops. The first year I times by 1.03. The second year I times by 1.02. The third year I times by 0.95. That would get me the exact same answer by doing it all in one line. Exactly as Evie just said. Okay? So really well done. Good job for spotting that. So times by 1.03, times by 1.02, times by 0.95. And we get the exact same answer. And I've done it in one line. Really well done. Well spotted. And that is the fastest method and the one that I use. Okay, I had to show you the long method so you could see that the bottom method works. If I just wrote the last line, it might have confused some people, okay? But I'm hoping that makes sense. I'm really impressed, by the way. Well done. Really well done. Is anyone unsure of this third method? Because it's what I'm going to be using from now on. Because it does it in one step, which gives you 3 marks. So you can do it in about 20 seconds, 25 seconds. Give you a few seconds. Perfect. Really well done. Okay, so here's a more standard question. Okay, you can definitely see something like this coming up in the the calculator paper. So again, we have Leanne invests £2,500 for 4 years, 3% compound interest. So I'm going to write out the equation again, but you probably don't need it. Right, the final amount is the initial multiplied by the interest to the power of the number of years. So in this case, we want the final amount. The initial is 2,500. The interest is 3%. I actually don't know the answer, Lila. I will definitely check it though. So it's 1.03. It's a 3% increase, and it's 4 years. So if I sub all of that in, let's see what we get. 2,500 times by 1.03 to the power of 4. 2813.77. Well done, Lila. Perfect. And that's 2 marks. Not too bad. Not too bad at all. Okay. So again, this is going to be fairly repetitive, so I want to test you guys. Right. So again, we have 9,500 times by the percentage increase 1.018. It's about 5. Again, it's just a couple of questions that might be a bit repetitive, just to make sure you're 100% okay. Just a piece of advice, just in general with GCSE Maths, is whilst you're doing it in a lesson, it's very easy to say, okay, I get it, that's good. But you will forget it over time. So make sure you're kind of keeping consistent with doing questions outside of the lessons, or just going over your notes. 386.34. Okay. Not bad, right? Perfect. Okay, I'm really impressed that you guys are managing this. So, for this question, you can do it. I'm going to show you the really shortcut way. Actually, I'm going to show you the slightly longer way, right? So, we have a very similar question to the previous question where I showed you the shortcut. Okay? But instead it's depreciation. So if it depreciates by 30%, that's the same as being 70% of its value, so 0.7. Decreases by 14%, that would be 86%, which is 0.86. So if we did this all in one line, you have 18,000 multiplied by 1 year of decreasing by 30%, multiplied by 0.86, and how many years does it decrease by 14%? Well, it's the second and third year, so it would be 2 years. And in total, we have 3 years done. Is anyone unsure of that? So again, I've done it in the shortcut method that I showed you earlier. So if it doesn't make sense, now would be the perfect time for you to let me know. And we can go over the shortcut way again. Wait, so Evie, is that you don't understand, or is it okay? It's okay? Cool. Perfect. So again, hopefully you can see how powerful that method is. It's a 3-mark question, which normally means you need 3 lines of working out and you need to do all this other stuff. You can do it in 1 step. So it's a really good way to save time in the exam, so you can use it for the harder questions. Or at least that's the idea. Okay. Sounds like everyone's okay with that. Interest can be a tricky topic. So really well done if you're understanding it. But again, keep up with it. Okay. So we've practiced that a bit. Now here, the next 2 questions involve something that's slightly different. Okay? So we have Nick bought a new car. It doesn't tell us the value. Each year, it depreciates by 12%. Work out the number of years it takes for the car to half in value. Give you a second just to accept that. Ah, Lila, impressive. Okay. I'll show you a trick on that. Once again, I'm going to show you 2 methods, okay? But this is one example of trial and improvement, which is something that's in every single spec. So Edexcel, AQA, CIE, doesn't matter what you're doing. Trial and improvement is a key thing that they test across all boards, okay? And this is an example of it. Really well done, Lila. In short, you start counting from the first equals, okay? So, 12% depreciates, so that would be 0.88, right? Now, each time we apply this, so after the first year, it's gone to 0.88 of its initial value. The second year, the way I work out what percentage it's going to be is I do 0.88 squared. Because it's 88% of 88%. And that gives me to 0.77. Okay? So I need to keep going. For it to half in value, it needs to go down to 0.5. Okay? Third year, I'm doing 0.88 cubed. 0.68. And again, if you want, you can actually jump, right? So I could go straight to year 5 and see what it looks like. But just for demonstration, I'm going to keep going until I get below 0.5. That doesn't count, it's 0.59, so 0. Then dot dot dot. I expect this one to be the correct one. Oh no, never mind, it's another one. 3. Keep going. Okay. So this is a fairly tedious method, right? 0.46. So in short, it takes 6 years because that is the first year that it's below 0.5. So are you guys okay with that? Okay. I'm going to show you a slightly easier method. It's easier on the thumbs. So you don't have to write it all out every time. Is that okay? Yeah, perfect. Okay. Now here's my shortcut, super easy method. And once again, as always, it uses the answer button. Okay? 0.88. So after the first year, how much? What's the percentage? I press equals it's 0.88. Okay, that's 1 year. Okay, so if you want, you can keep a tally, but I'm going to keep my thumbs up instead, right? The next year, I'm just taking that original amount and timesing by 0.88. What's that going to give me? The second year. And if you notice, it's the same. The next year, it's going to be again 88%. So I press equals 3 times, 4 times, 5 times, 6 times. That's it. You just count the number of times you press equal. So it's the A and S button, and you just count the number of equal times. Count the times you press equals. Are you guys okay with that method? And hopefully, the reason why I wrote all of this out is that you could keep track that it does actually work. Okay? That every year it matched up perfectly. Yeah, perfect. And Lila, did that answer your question about when you start counting? You count from literally the first one when you save it as the answer button. Perfect. That's exactly what I like to hear. Okay. Next question is very similar. Once again, it's trial and improvement. So trial and improvement. And once again, there are multiple methods on doing this, okay? In the same vein as above, there's a longer way and there's a shorter way. And once again, I'm going to start with the longer way because then you appreciate the short way, okay? I'm not sure how to pronounce his name, actually. I think it's Fiern, but I'm not 100% sure. Invests £5,600 in a savings account and she gets 2% per annum, so per year, compound interest. After N years, she has £6,061.62 in her account. Work out the value of N. Cool. So, first year, she's going to have 5,600 times by 1.02. We all agreed? So 5712. Now, because it's compound interest, we now take that new amount, right? So 5712 and times it by 1.02 again. You can also do the thing where you square it and then cube it and then to the power of 4, right? Like increase the power. That also works. So if instead of changing this first number, you just put a power here, that will give you the same answer, okay? You get 5826.24. 3 years. Again, I take that value. There's a reason why I'm doing it this way though, because I want you to see that we can just use the answer button, okay? 5924. Sorry, 42 even. I'm really hoping it's the next one. I'm actually 100% sure it's the next one. 5942.7648. There we go. So right, so N is 4. Now once again, right? And you could have done this with powers, by the way. So you could have done, for the second year, you could have done this, right? To the power of 2 equals, see what that equals, change it to a 3. And if you can see, it's giving me the exact same answer, right? I actually wrote down the wrong amount. But yeah, gives me the same answer. So what you can do again is do 5,600 times by 1.02. That gives me the first year. Then if you just press times 1.02, that gives me the second year, third year, fourth year. I get my answer. That easy. You can save a lot of time doing it that way. Okay? And once again, you can also count from the first equal sign, right? Are you all okay with that? Whoops. All good. You don't. So your maths teacher's slightly incorrect, right? So you actually don't need method marks. So what I might do, right, is I could have gone straight from the first year and guessed the third year and then went to the fourth year, right? That is fine, okay, because it's trial and improvement. So you don't need to write the third year, right? Or you could have gone from 1 to 2 and then straight down to 4, okay? You don't need to do it. I guarantee it. So you don't need to write all of them down. I'm writing all of them down just so you can see that the quick method works the same as the slow method. It gives you the same results each time. I don't want you to just believe me, I want to show you. Okay. Give you a few more seconds for any other questions. Okay. So we don't have many more questions because this is a fairly short topic. But the last thing is you always have, again, this is across every single exam board, is you have something called best buy, where basically you need to compare two things and see which one's better value for money. So it could also be value for money is what it could be called. Okay? Which is useful in real life. Okay? Really useful in real life. Okay? And you need to compare which one will give you the best value, right? So how much money you get. So I want to change something. In this question, instead of some money, just for demonstration, can I change this to £2,000? And I'm going to do this question again, but without money. Okay? I hope that that isn't complicated. Just for now, I want to show you an example with money specifically, okay? So Alice is going to invest £2,000 for 5 years. She can either choose investment A or investment B. Yeah? Investment A is 2.7% compound interest. Investment B is 2.8% simple interest. So compound interest, we're experts at that now. Let's just work this out. You would have £2,000 times 1.027, and I'll put a bracket to power 5, right? So let's do that. We have 2,000 multiplied, whoops, sorry, I pressed X instead of times, 1.027 to the power of 5, right? And let me just double check that. Yeah, that's good. 2284.98. So just so you know, the best value for money in this case is whichever one has the most amount of money after 5 years. Okay? Now I would like to point out that compound interest is better when you have bigger sums of money. Okay? I've chosen a very small amount of money, but that's just to be clear. 2.8% simple interest. So the way I work this out is I work out what 2.8% of 2,000 is. Right? Best way to do that is you take that as a percentage, a decimal, and times it by 2,000. Right? I'm hoping it's not too bad of a number. I don't think it will be. 56. Well, that's a really easy number. Cool. So we haven't done simple interest. 100,000% it will. Definitely. It has to. This is a bit advanced, but just so you know, it's compound interest, right? If it's a lower rate, is worse in the short term, better in the long term. Okay? So at the beginning, obviously after the first year, because the interest rate is lower, you have less money. But it builds up over time. You won't need to do either. It gives us 5 years. Okay? And it will always give you a time frame. Okay? So all you need to do is work out after 5 years how much money would be in the account if you did with compound interest and how much would it be with simple interest. Okay? Whichever number's bigger, that's the one you go with. But very good questions. Okay? If you're talking about for you personally, what would be better, then you'll talk about long-term, short-term, and things like that. But in exam questions, they give you a time frame, okay? Really good question, though. So with simple interest, we said at the beginning of the lesson that the amount doesn't change. So what I'm effectively doing is I'm taking my £2,000 and I'm adding 56 for every year that I'm investing. So it's 5 years, I'm adding 56 5 times. Whoops. Now that is incredibly tedious. So instead of adding, I don't know why I wrote 20,000, sorry. Instead of adding 5 times, what you can do is do 5 times 56. And those two things are equal to each other. Okay? Hopefully that should make sense. But again, if you're not sure, please let me know. We get 2280. Yeah. Perfect. Okay. Generally speaking, compound interest is better, but only if the interest rate itself is comparable, if it's similar. Okay? So which one's better value for money? Or in this case, which one's better? Which investment should Alice choose? It's investment A. So the way I like to do it is I always imagine myself in this situation. Would I rather have £2,284.98 or just 2,280? Well, obviously, more money, right? That's 4 marks, so quite a lot, but it's not that bad. But are you guys okay with that? Yeah? Perfect. Hopefully I've explained it well. That's good. Okay. And this is where it gets interesting, okay? So this is also something they like to do. So they're both compound interest. So Matt wants to invest 8 grand for 3 years. There's 2 banks. But the interest rate is fixed for Bank A, which is 1.2% every year. But for Bank B, it's higher in the first year, lower in the next 2. So which bank will give Matt the most interest? So once again, I'm going to split my thing in half. And this is exactly what I recommend you do in the exam. And work out the difference, right? So again, Bank A's easy. I don't doubt that you guys can do this, right? Take the £8,000, times it by the percentage increase, so it's 1.012, to the power of the number of years, which is 3. Let's do this nice and quick. And again, round it to 2 decimal places, so we get 8291.47. Okay? Now we're going to use Evie's suggestion for this next one, right? We're going to chain it along. So we have the £8,000, and for the first, oh God, I wrote 80,000. £8,000. For the first year, the interest is 1.02. Then it goes down to 1.01 for every additional year. How many years do we have left? We're doing it for 3 years. 1 year is 2%, so we have 2 more years left. Okay? So what I'm going to do is 1.02. Right. You don't technically need the brackets, to be honest. 1.01 and then make that to the power 2. 8324.02. So which bank should he go with? Or which bank has the most interest? Well, it's Bank B. Again, that's 4 marks. So your papers for most exam boards are out of 80. So that's 4 out of 80 you get for this. And we did it in 2 lines on our calculator. 4 marks. So these are really good questions to kind of master. And I'm hoping that you guys are actually getting pretty comfortable with it already. But please keep up with it, okay? You have to keep doing questions every now and then. Because it's very easy to make mistakes, especially when you do things like chaining this along, okay? Any questions about that? I think it's all okay. Wonderful. Okay. Again, great to hear it. Again, this is a very similar question to what we've just done. Very, very similar. Okay. So Melvin invests 5 grand, 2.5% every year, and Charlie invests 4,500, paying 3% every year. Work out the difference in money. It's the same thing, but imagine this is Bank A, Bank B. That's the only difference, right? They've just changed it to people. So we do Melvin. We only need a bit of space. And Charlie. So let's work out the difference, right? It's not too tricky. So Melvin, he has £5,000. The interest rate is 1.025. Number of years is 5 years. There we go. Same as what we've done before, okay? So 5, 1, 2, 3 times by 5. 5657.04. And with Charlie, it's 4,500, but it's a higher interest rate. So let's see if it's any better. So what I'm going to do is just edit my equation, again using the arrow keys, just so I don't have to do the same thing over and over again. 5216. So it seems like Melvin was better, so he invested more money to begin with a lower interest rate, but it seems like he's made it out on top. But the question actually says, work out the difference in money. So what we need to do now is do 5657.04 subtract 5216.73. Let's do it. So 5657.04 subtract 5216.73. That's it. £440 and 31 pence. Right. And that's 4 marks again. Look how quickly we get this done. 4 marks should be roughly 4 minutes, and yet we've only written this much. And look how much space they gave you too. Really useful questions to kind of smash out. Okay, I'll leave that on the board just for 2 more seconds. That's a really good question, Lila. More than likely, it would just be 1 question in your calculator paper. So that'd be paper 2 if you're doing Edexcel, paper 5 if you're doing AQA, and so on. But normally it's only 1 question. So I have a few more kind of, basically what I've done is I've actually gotten questions from every single exam board. Okay? So this first one is Edexcel. Okay? The next one, so for some reason the labeling actually got a bit weird. And I've written where I've gotten the question from. So this is Edexcel Paper 2 2020 Higher. There's one for AQA and OCR as well, just to show you that it's literally every exam board. Okay? So for this question, a car is bought for £1,500 but depreciates in value 8%. So in other words, 0.92 because it's at 92% of its value every year. How much is it worth after 2 years? Well, 1,500 times by 0.92. How many years? 2 years. Okay. So the questions are all very similar, always. $1269.6. And then it says, what is the total depreciation after 2 years? So this number as a percentage. So to change anything into a percentage, what we're going to do is take the new value, which is this, divided by the original value times by 100. That's it. To change anything into a percentage, you take the current value, divide by the old value, times by 100. And then times by 100. And you get 84.64%. Not bad. And that's the actual question from Edexcel. Next, I believe, is OCR, and then AQA is the last one we'll do. Give you a few more seconds to ask any questions you might have. Cool. The next one, again, the labeling did get messed up. This is OCR. Whoops. Oh, come on, be faster. OCR, November 2019, right? Perfect. Joan invests £6,000 in a savings account. The savings account pays a compound interest at a rate of 2.4% for the first year, 1.7% for each extra year. Work out the value of Joan's investment at the end of 3 years. The reason why it says Part B is because Part A was unrelated. So I cut it out, okay? But if you go to OCR 2019 November, you'll find this exact question, okay? So again, this is the exact same thing we've just been doing, right? We take our £6,000. The first year is 2.4%, so that's 1.024. We do one more question after this, and then we're done, okay? Unless you guys have any questions, then we'll continue for a bit. Then 1.017. At the end of 3 years. Okay. So, the wording of this question is a bit interesting because that is valid, right? Why don't we take it from 100, right? So, this is the actual value of the car expressed as a percentage of the original value. So, what Lila's saying, which is 100% valid, why don't we do this? Okay, so you do 100 minus the answer 15.36. And this is actually my bad. I didn't mention this. In the mark scheme, because the question is a bit vague, they do actually reward marks for both of these. Okay? Yeah. So as a percentage, so the way I interpreted it and the way Lila interpreted it was slightly different, but both are actually correct. Okay? I've expressed the new value as a percentage of the original value, which is kind of what the question's saying. But Lila's pointed out that the actual depreciation would be 100 minus that. That also works. So both of these are correct even though they're different answers, which might seem a bit scary and weird, but both of those are actually correct. Okay? But yeah, very good point. And this value would be squared because you have this interest rate for 2 years. Okay, so 1 year of 1.024, and then you have 2 years of 1.017. So 6354.67. All good. And again, it's the same thing we've been doing. This is completely universal. It's for all exam boards. The last question is from AQA. Again, apologies for this being a bit wonky. And again, just in the interest of time, it's a very similar question, right? You're working out the compound interest. Okay. So hopefully you can see that it is the same no matter what exam board you're doing. It can be a bit tricky, of course, but it is all the same kind of stuff, okay? Is any of that confusing? Okay, that's good. Perfect. Let's hear it. Are there any questions about that? So I know that, I think it was you, Evie, that asked about the kind of exponential equations. Hopefully you can see that these do take on the form of exponential equations. But can I ask kind of what style of question, was this the thing you were talking about, or is there a different style of question you wanted to go through? Because there is quite a bit on exponential equations. And again, we will cover it over the coming time. Using the graphs, okay. What I'll do is I'll note that down as something that you want to go over, and I'll try and slot it into one of the future lessons. Okay? And substituting values, yeah. No worries. So modelling with exponentials, basically. I will try and slot that in, okay? A bit later. But yeah, if there are no questions about this, then we'll call it equation of circle. Oh yeah, 100%. That's coming up too. We're going to cover all of the GCSE spec, okay? But yeah, absolutely. And yeah, so if that's all okay, then we can probably call it quits there. But yeah, all of that stuff is coming up, definitely. But yeah, if there are no other questions about this, I hope that you found this useful and I know maths can be very repetitive, but hopefully you enjoyed it a little bit. Hopefully I made it ever so slightly fun. But also hopefully you understand it. Okay? You're more than welcome, Lila. Thank you for that. You're welcome, Evie. Thank you. And again, thank you for turning up and thank you for interacting as well. Okay? It makes the lessons a bit more fun for me as well. But yeah, if you have any suggestions or have any requests, please let me know. I'm more than happy to change the lessons. I'm hoping just going through exam questions is a good way to teach you. I find that it is, but some people learn differently. Yeah, other than that, I'll let you guys get on with your evenings. And I'll see you next week.